Let's do this problem from our lab assignment, section 2.7. It says that they want us to find the derivative of the function evaluated at a, so that's f prime of a. Our function is 9t plus 17 in the numerator divided by t plus 4 in the denominator, and we will use the definition of the derivative evaluated at a point. So our formula is f prime of a is equal to limit as t approaches a of f of t minus f of a in the numerator divided by t minus a in the denominator. So our function f of t is 9t plus 17 divided by t plus 4. And so we're going to just drop the whole function in for the first part of the numerator minus, we're going to put that function evaluated at a. In a, we don't know what a is, and so we're just going to have to keep it as a variable a. So it's 9a plus 17 divided by a plus 4. And then divided the whole thing. So remember that the first part is just f of t, and then the second part is just f of a, and then in our original function we still have a t minus a. Alright, now we're going to get some algebra work done here by figuring out what the whole numerator is equal to. So the numerator is a couple of fractions, and to add fractions we're going to need to find common denominators. So it looks like our common denominator will be the denominators of the fraction t plus 4 and a plus 4. And so if we're going to have that as a common denominator, we're actually going to multiply the first expression here by a plus 4 divided by a plus 4. So the numerator will become 9t plus 17 times a plus 4, and then our denominator is going to be t plus 4 times a plus 4. So that's the first part. And then we're going to multiply the second rational function by t plus 4 over t plus 4, and that's why there's a t plus 4 here. And then now that they have the same denominator, they combined it into one denominator. Okay, so we have this big numerator that we want to simplify, and so they took the liberty of distributing, foiling out the first part as well as the second part, and they made sure to keep track of the negative signs as it got distributed. So they did that step for us, and then now the last step here is they want to combine all the ones with, let's take a look at the 9ta here and the negative 9at, so that disappears. And let's look at the positive 68 and the negative 68, and that disappears. So all we have left are a couple of expressions with t's and a's. So we have a 36 and a 17. So 36 minus 17, that might be 19. And those that's going to be the coefficient of the t's after everything's got simplified. And then there's a minus sign here, and then the coefficient of the a is 17 minus 36. So 17 minus 36 is negative 19 as well. And the negative is outside already, and that's 19. So let me just double check that 36 minus 17 is actually 19. Okay, better. So let's go ahead and submit that. So that looks good so far. And now the numerator, remember that we had just worked on the numerator, and this is just the numerator. So our whole numerator will go into this expression, And what they did was they took the numerator and they took the denominator that we got from the numerator and merged it with the denominator that they got. So this is all algebra. This is all algebra. And if the steps here, if the steps they're skipping is not clicking with you, then I suggest you actually do this from scratch, and you'll see that when it all gets simplified, you'll get this expression. Okay, so what they're going to do now is they're going to cancel after we take a look at this numerator and we see that there's a 19 in common. We can factor out a 19. We get t minus a, and there's a t minus a here as well. So we're going to cancel the t minus a on the numerator, and we'll be left with 19, and we'll cancel the t minus a in the denominator. So that will leave us a 19 divided by this big business. And then now that we have that, we can take the limit as t approaches a. And so as t approaches a, we'll see that there's going to be no more issues about having zeros in the denominator. But that, by the way, was our issue in the beginning. If you let t equal to a from the beginning here, you're going to get zeros in the denominator and 0 in the numerator. So because there was a 0 in the numerator and a 0 in the denominator, there's a chance that we could do some algebra and cancel things out. And in fact, that's what we did. So now we can safely put in t is equal to a, and that's going to give us a 19 in the numerator, and our denominator is that when this becomes a, this is a plus 4 and a plus 4. So we can just call that a plus 4 squared, and that should be the derivative evaluated at a. Okay? All right, so hope that helps.